Chemical reactions and equations. Milk is left at room temperature during summers, the milk becomes sour. An iron tawa or pan or nail is left exposed to humid atmosphere, so it looks rusty. Grapes get fermented. Food is cooked. Food gets digested in our body. We breathe through the nose. What a change we see in all situations. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. How do we come to know that a chemical reaction has taken place? Let us see some activities. Activity. Clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. Magnesium oxide is formed due to the reaction between magnesium and oxygen present in the air. Activity. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid. You will see something around the zinc granules. Touching the conical flask, we will notice a change in its temperature. The process of dilute sulfuric acid on zinc produces hydrogen gas. Based on this activity, we can say that change in state, change in color, evolution of a gas and change in temperature, any of these observations are used to determine if a chemical process has taken place. Chemical equations. When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. Can be written in a shorter form. So it is written like this in the form of a word equation. Magnesium plus oxygen gives magnesium oxide. The substances that undergo chemical change in the reaction, magnesium and oxygen, are the reactants. The new substance, magnesium oxide, formed during the reaction is the product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left-hand side with a plus sign between them. Similarly, products are written on the right-hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Any chemical reaction can be represented by a chemical equation. Magnesium, oxygen, as well as magnesium oxide if we use chemical formulas instead of word equation. Mg plus O2 gives MgO. Count and compare the number of atoms of each element on the left-hand side and right-hand side of the arrow. Is the number of atoms of each element the same on both the sides? If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation Mg plus O2 gives MgO is a skeletal chemical equation for the burning of magnesium in air. Balanced chemical equations. Law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. The number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation. Zn plus H2SO4 gives ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow. Element Zn. Number of atoms in reactants equals to 1. Number of atoms in products equals to 1. Element H. Number of atoms in reactants equals to 2. Number of atoms in products equals to 2. Element S. Number of atoms in reactants equals to 1. Number of atoms in products equals to 1. Element O. Number of atoms in reactants equals to 4. Number of atoms in products equals to 4. As the number of atoms of each element is the same on both sides of the arrow, equation is a balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O gives Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Fe plus H2O gives Fe3O4 plus H2. Step 2. List the number of atoms of different elements present in the unbalanced equation. Element Fe. Number of atoms in reactants equals to 1. Number of atoms in products equals to 3. Element H. Number of atoms in reactants equals to 2. Number of atoms in products equals to 2. Element O. Number of atoms in reactants equals to 1. Number of atoms in products equals to 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the right-hand side and only 1 on the left-hand side. To balance the oxygen atom is initially 1 in reactants and 4 in products. So 4 atoms of oxygen have to be added in reactants to balance. To equalize the number of atoms, we cannot alter the formula of the compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4 or H2O4. Now the partly balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. Hydrogen atom is initially 8 in reactants and 2 in products. So 4 atoms of hydrogen have to be added in products to balance. The equation would be Fe plus 4H2O gives Fe3O4 plus 4H2. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Iron atom is initially 1 in reactants and 3 in products. So 3 atoms of iron have to be added in reactants to balance. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. The numbers of atoms of elements on both sides of equation are equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make many trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notations G, L, AQ, and S respectively. The word aqueous is written if the reactant or product is present as a solution in water. The balanced equation becomes 3FeS plus 4H2O G gives Fe3O4S plus 4H2G. Note that the symbol G is used with H2O to indicate that in this reaction, water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, COG plus 2H2G at 340 atmospheric pressure gives CH3OHL 6CO2AQ plus 6H2OL in the presence of sunlight and chlorophyll gives C6H12O6AQ glucose plus 6O2AQ. Types of chemical reactions. During a chemical reaction, the bonds between the atoms in the reactants break down and new bonds are formed, resulting in the formation of a product. Combination reaction. The process by which a product is formed from two or more reactants is called a combination reaction. Activity. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker. Touching the beaker, we can see that its temperature changes. Calcium oxide is very strongly processed with water to form lime and releasing a large amount of heat. CaOS plus H2OL gives CaOH2AQ. Let us discuss some more examples of combination reactions. First, burning of coal. Cs plus O2G gives CO2G. Second, formation of water from H2G and O2G. 2H2G plus O2G gives 2H2OL. When two or more substances combine to form a single product, the reactions are called combination reactions. Large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Other examples of exothermic reactions are: first, burning of natural gas. CH4G plus 2O2G gives CO2G plus 2H2OG. In this process, methane and oxygen are processed to form carbon dioxide and water. Second, we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration. C6H12O6AQ plus 6O2AQ gives 6CO2AQ plus 6H2OL plus energy. Third, the decomposition of vegetable matter into compost is also an example of an exothermic reaction. Decomposition reaction. Activity. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. The color of the ferrous sulfate crystals is light green. Heat the boiling tube over the flame of a burner or spirit lamp. After heating, the color of the ferrous sulfate change into light green to reddish brown and also smell the characteristic odor of burning sulfur. 2FeSO4S in the presence of heat gives Fe2O3S plus SO2G plus SO3G. Crystal of the ferrous sulfate decomposes. It turns into ferric oxide, sulfur dioxide and sulfur trioxide. Ferric oxide is a solid, while SO2 and SO3 are gases. Ferrous sulfate crystals lose water when heated and the color of the crystal changes. In this reaction, a single reactant breaks down to give simpler products. This is a decomposition reaction. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. Calcium carbonate decomposes into calcium oxide and carbon dioxide when heated. Activity: take about 2 gram lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. Heating the lead nitrate powder produces brown fumes. These fumes are of nitrogen dioxide. Thus, heating lead nitrate produces lead oxide, nitrogen, oxygen. Activity: take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. The volume of the gas collected is not same in both the test tubes. Once the test tubes are filled with the respective gases, remove them carefully. Test oxygen and hydrogen gases one by bringing a burning candle close to the mouth of the test tubes. Thus, observations show that oxygen gas present in one test tube and hydrogen gas present in other test tube. Activity: take about 2 gram silver chloride in a china dish. The color of silver chloride is white. Place this china dish in sunlight for some time. After a while, observing the color of silver chloride, it will be seen that it will be brown in color. After some time, it is observed that in sunlight, silver chloride converts to brown color and becomes a silver metal. This is due to the decomposition of silver chloride into silver and chlorine by light. 2AgClS in the presence of sunlight gives 2Ags plus C12G. Silver bromide also behaves in the same way. 2AgBrS in the presence of sunlight gives 2Ags plus Br2G. AgCl and AgBr are used in black and white photography. The decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Displacement reaction. The process of removing compounds from a solution is called displacement reaction. Lead and copper chloride are processed to get lead chloride and copper. Zinc and lead are more reactive elements than copper. They displace copper from its compounds. Activity: 3 iron nails, sandpaper. Test tubes, copper sulfate solution. Thread. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Copper sulfate solution in the test tube B shows a change in the color of the dipped nails compared to the separate nail. The color of the nail becomes brown. The brown color fades in copper sulfate solution of test tube B as compared to test tube A. Because in this process, iron displaces copper from the solution of copper sulfate. The following chemical reaction takes place. Iron and copper sulfate are processed to get iron sulfate and copper. Other example. Zinc and copper sulfate are processed to get zinc sulfate and copper. Double displacement reaction. If ions are exchanged between two reactants, that is called double displacement reaction. Activity. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Now, by mixing two solutions, we get barium sulfate and sodium chloride. White substance which is insoluble in water is formed. This insoluble substance formed is known as precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Na2SO4Aq plus BaCl2Aq gives BaSO4S plus 2NaClAq. The white precipitate of BaSO4 is formed by the reaction of SO4 2- and Ba2 plus. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions.